Today's Daily Go problem of the day is Alice and Bob playing Flower Game number 3021. The description for this problem is terrible in my opinion, so I'll try and kind of um, avoid just stating what it says here and summarize what it means. So it says Alice and Bob are playing a turn-based game, and there's two lanes or two rows of flowers between them. There's X flowers in the first lane and Y flowers in the second lane, so we could label each lane like X and Y. So the game will proceed as follows. Alice will always start first. Alice always starts first here. Each turn, a player will grab a flower from one of the lanes. And then at the end of a turn, if there's no flowers left, the player who took the last flower wins. So all we're doing is selecting flowers one at a time. And Alice always goes first. So Alice will pick a flower, Bob will pick a flower. Alice will pick a flower, Bob will pick a flower. And it just keeps going like this. So Alice, Bob, Alice, Bob. And we would notice that Alice gets the last flower in this example image up here. Now, a pattern that we can note in situations where Alice wins is there's an odd amount of flowers. Just simple turn-based game. If she's starting first and there's an odd amount of things to pick, she's going to win. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 flowers here. Alice is going to win because there's an odd amount of flowers. If there were an even amount of flowers, Bob will always win. So our goal is to return the number of possible pairs or positions. This is very confusing way to word it, that satisfy the conditions met. So we're looking for the amount of possible positions that Alice can win from. So these possible positions always need to add up to an odd amount of flowers. So this would be a valid amount where Alice can win. This would be a valid amount where Alice could win. This would be a valid amount where Alice can win. Basically, we're always going to select an odd amount of flowers. That's how Alice can win. So starting with one total flower, Alice can win. We could scroll down here and see the two examples we are given. In example 1, the first row has 3 flowers. The second row has 2 flowers. Automatically, that's an odd amount of flowers. So we know Alice can win. And that is one of the situations that add up to an odd amount of flowers. So that is a winning position for Alice. 2 and 1 is also a winning position because that's an odd amount of flowers. And 1 and 2 is a winning position because that's an odd amount of flowers. In the situation where we have 1 and 1, so 1 flower in each row, there is no winning position for Alice because we always have those 2 flowers, right? We can't just get rid of one. It's confusing, but basically we're always looking for an odd position for Alice to win. So as long as we have an odd position, Alice will win. And we also have to take note that we have to return a long here, simply because the numbers can get really big. So the first thing we're going to do is convert our answer to a long. The second thing we're going to do is understand how these numbers work. So we have 1 to n, and we have 1 to m. Well, if we take m or n, let's take n for example, and say that's equal to 6. Well, basically we're going to have 1, 2, 3, 4, 5, 6. Half of the numbers in n, half the numbers in n are going to be even, half the numbers in n are going to be odd. So we have 1, 2, 3 odd numbers, 1, 2, 3 even numbers. So for a position to be valid, we're going to take one even number and add it with one odd number. And so we're going to take one even number from n and add it to one even number of m. Let's say m is 6 as well, right? Just to make our situation easy. This is a winning position for Alice. This is a winning position for Alice. This is a winning position for Alice. This is also a winning position for Alice. And this is also a winning position for Alice. And then 6 and 1 would be a winning position for Alice. Now, one thing we can note is we're going to basically use half of the even numbers and we're going to use half of the odd numbers no matter what. So our solution is simply going to be all the numbers in n times all the numbers in m, and then we're going to divide it by 2. So if we run this, passes our test cases, and if we submit it, that is our solution because we're going to use all the even numbers from n and all the odd numbers from m, and those are going to be all of our winning positions. So that's it for this problem. Thank you, and follow for more daily LeetCode solutions.